The center of mass. The student brought me a problem and I was a little befuddled because I couldn't figure out why the answer was what it said it was because it didn't make sense to me, and it turned out I didn't understand the problem. So let's take a look at the problem and the answer. So we have two ice skaters starting from rest, hold on to the ends of a 10-meter pole. We have a 40-kilogram player at one end, 60-kilogram player on the other. The players start pulling themselves along the pole towards each other while sliding without friction. That's key, without friction on the ice. If the two skaters continue past each other after they meet, what distance will the 60-kilogram player have moved with respect to the ice when the skaters have exchanged positions with each other? So you probably have learned that in the absence of an external force, so without an external force, the center of mass is constant. So wherever the center of mass is right now, the center of mass will stay there as long as there's not an external force. And in this problem, there is no external force. We're just talking about the two people and the pole. And they're sliding on the ice without friction, so there's no extra force there. And you've probably learned a formula, something like this, that the coordinate of the center of mass is the sum of each of the positions times the mass over the sum of all of the masses. And so let's see how we can apply that to this problem. So we have, let's have a coordinate system. Oh, that's lovely. Let's try this again. Much better. All right, so we've got our coordinate system, and we'll just define a 0. And I am going to say that you could do this in different sorts of ways, but I'll start by putting our pole right here so that it is at 0. And so that we have our 60-kilogram person at 0 when we start. And our 40-kilogram person at 10 when we start. So this is how we start. And so to find our center of mass, we'll take our sum of our masses times their positions over the sum of the masses. So our first mass is 60 kilograms, and that person is at 0 meters, plus our second person is 40 kilograms, and she is at 10 meters, and we sum up our masses, 60 kilograms plus 40 kilograms, and so that ends up with being 40 kilogram meters over 100 kilograms, and the kilograms cancel. Sorry, that would be 400 kilogram meters. The kilograms cancel, and we can cancel out the zeros, and we get 4 meters. So our center of mass in our coordinate system is at 4 meters. That center of mass can't move. And so when I read the problem and I see that they pull themselves towards each other, and I say, well, when they meet, they have to be at that center of mass, because when they meet, if this is 4, and they're right here, the center of mass obviously is at 4. So when they meet, the center of mass is obviously at 4. So I was confused because I said, well, the 60 kilogram person has to move 4 meters. But the answer is 8 meters. So what I didn't understand until I went back and read the problem is it says that they are exchanging positions with each other. And so what that means is they are holding on to this 10-foot pole, and as they move, they're going to be moving to opposite sides of the pole, and as they do, the pole moves as well. And so the pole is going to be sliding the pole, if I can grab it. No, I don't. I do not want to do any of those things. See, is it going to let me move it? Yeah. So the pole is going to move that way. Now, how do I know that? Well, at this point, I don't necessarily know it, but what I do know is that they are going to change places. And so if they change places, then I'm going to end up with some situation where I've got the 40 kilogram person here and the 60 kilogram person here. And wherever they are, if they've changed places, and then they are still going to be 10 meters apart because this pole is 10 meters apart. So if they've swapped places, they're still going to be 10 meters apart. And then by the same reasoning that I used at the beginning, we know the center of mass has to be 4 meters away from the 60 kilogram guy. So this has to be 4 meters. And this has to be 6 meters because it has to be 4 meters away from the 60 kilogram guy. If you wanted to work it out again, you could set like this as the 0 point and then figure out that the center of mass would be at 6 meters away. Okay, but if the center of mass is 6 meters from the 40 kilogram person, but the center of mass its position hasn't changed. Center of mass still has to be right here at 4 meters away from where we originally said our origin was. And so if the center of mass is here, and our 60 kilogram person is here, and our 40 kilogram person is here, then what has to have happened is that our 60 kilogram person had to move the 4 meters to the center of mass, and then the 4 meters to get to the other side. And the pole slid, everything moved except for the center of mass. At any point, the center of mass was always there. So what we had is now that our 60 kilogram person moved a total of 8 meters. So he moved 8 meters, and when he moved 4 meters, and they were lined up at the center. And then after they were lined up at the center, and they continued on, so they were lined up at 4 meters, so they were at 4 meters, relative to our origin, our starting point. And then the 60 kilogram person continues this way, the 40 kilogram person continues this way. And we don't know where the pole is, but we know the center of mass still has to be at x coordinate 4. And if the center of mass has to be at x coordinate 4, and we also know that if we called, this is 0, but if we called this point 0, we would have to have 6 meters here and 4 meters here. Or in other words, we know that the center of mass always is going to, if we had it at, when we had it at 10 meters, the center of mass had to be 4 meters away from the heavier person. So the total distance that that person traveled was 8 meters. Now, just for fun, if you are interested in this sort of thing, if you're not, you can stop this video now. Let's say that we had the same problem. This time we just have this rod of length L, and we have a person of mass M1 and a person of mass M2. And we want them to exchange positions, and we want to know how far did person M1 move relative to the ground or the ice or whatever it is as they exchange positions. So it has to be ice because we don't want any friction. That's ice. So let's do this carefully. So if I set this to be my 0 point, then my center of mass, my x center of mass, is m1 times 0 plus m2l over m1 plus m2, or m2l over m1 plus m2. And the center of mass has to remain there. Okay, so now they exchange places. So now we don't know where 0 is, but we know that the center of mass, wherever that happens to be, m2l, m1 plus m2, that has not moved. That's going to be in the same place. And now we have m1 here, and we have m2 here. And this is length L. Now if we go back and look at our original drawing, we don't know where the center of mass is, but we know it is at m2l over m1 plus m2. And if we called that 0, that's what this distance is. This distance has to be L minus m2l over m1 plus m2. And that's not written very well, so it has to be L minus that. That's just the distance. Okay, so now they've switched places. The only thing we know the coordinate of is this one right here, but we know that this distance has to be, this distance has to be, that's the distance from M1, has to be M2L over M1 plus M2. And this distance has to be L minus M2L over M1 plus M2. And if the coordinate distance here is M2L, M1 plus M2, and this distance is also M2L over M1 plus M2, then the coordinate of mass M1 now has to be 2 M2L over M1 plus M2. It has to be wherever the origin is. So say it's right here, 0. We know the center of mass is right here. And we know that is this distance. And we know that M1 has to be that distance away from the center of mass. And so we know that. And so what is the x position of mass 1? It has to be this. What is the x position of mass 2? It has to be L minus that. So how would this work if our M1 is 60 and our M2 is 40? Then we would have that the x position of M2, of M1 is going to be 2 times 40 times 10 over 40 plus 60, which is 800 over 100, which is 8. So we get that he moved 8.